This right here, well, it is a pretty important piece of electronics, and today we're gonna have a closer look at it. And it's a voltage regulator. It regulates voltage. So for example, if we have an input of 20 volts and we want to bring it down to 12 volts, this piece of electronics can help us do that very efficiently. And in the past, or even in some cases right now, this little chip can replace this voltage regulator, but there's a pretty big catch. How this one works is that if we take the input of 20 volts and we want to get the output of 12 volts, this MOSFET right here is quickly switching on and off, on and off, on and off. It's called a pulse width modification, a PWM, and because of this, the voltage regulator can achieve efficiency of about 90%, whereas this little chip is relatively simple. An input, a ground, and the output. But the problem is that this chip is basically a big resistor. So if you have an input of 20 volts and an output of 12 volts, what it does is basically the difference of 8 volts. The energy is just dissipated in heat. In our scenario, it will have efficiency of just about 60%, but the higher the voltage, the higher the input voltage and the lower the output voltage, the efficiency will decrease with it. Whereas this bigger voltage regulator works on a different principle and has about constant efficiency of 90%, plus or minus depending on which components you use. And that's why I decided to put it in my PCB. Alright, so I'm here in the design schematic, and here you can see this is the chip, and this is the datasheet of the chip. It will be also listed down in the description. And you can see that the chip has 1, 2, 3, 4, 5, 6 pins, but the EP is the exposed pad or the exposed ground, so it doesn't really count, but anyways you connect it to ground. And then also ground is connected to ground. Win is connected, well, I have it connected to the switch plus. That's basically the input of this chip. And you also need to add a decoupling capacitor. Right here I use an aluminum capacitor with 470 microfarads at the maximum voltage of 16 volts, and the maximum input is 8.4 volts, so basically the threshold is double the maximum input voltage from the battery, so it should be really safe. And then I also decided to add a small ceramic 10 microfarad capacitor so that it can filter out those higher frequencies. And then you have the output pin, that's basically the 5 volts for me, and right here just needs to go through this inductor. I've selected the 33 microhenries, that's exactly the same value as in the datasheet, and then it's basically right here connected to the plus 5 volts. And then it's also, here I use the exactly same set of capacitors as right here, also for filtering and coupling reasons. And then here you also have a diode, and I believe it's there to filter out and balance the current and the voltage of the output pin. And then you can see the FB, that's not like Facebook, it means feedback, so it's a feedback pin, so that this chip can check the output voltage. And here you have the last pin, the on or off pin. It's there so that you can shut down the regulator or to turn it on. And if the voltage on this pin is below 1.3 volts, the voltage regulator operates normally, and if it's above 1.3 volts, it shuts down. So I don't know, you can use it for example for thermal protection. If you don't want to use it, you can left it floating or you can connect it to ground, and in that case the voltage regulator will be always operating. And if we have a look at the datasheet of this chip, so it's from Texas Instruments, and here we can see some basic information about it. The switching frequency, the maximum current rating. Here are the, for example, the 3.3 volt, 5 volt, 12 volt fixed options, or the adjustable output versions. Pretty cool. And right here on the first page you can see the typical application, and basically it's relatively same to what we have. The only difference is that I decided to add 2 more capacitors. So right here I added another ceramic capacitor, and the same goes for here. I just thought it would make it would filter out the voltage and the current a bit better. And I was able to put this voltage regulator on my PCB thanks to the sponsor of this video and the provider of the PCBs, PCBWAY. They are a manufacturing company producing variety of products like PCBs, PCB assembly, and 3D printing. They also have some metal stuff. And once you have the schematic and the PCB complete, you can export it to like the Gerber files, and then the bill of materials, and then pick and place files. You can head over to PCBWAY.com and you can go and upload them like so. And right here you are on the home page. You just click here in the PCB instant quote. Here you click to quick order PCB. You can add the Gerber file. And as you can see, it basically fills out this whole page for you. So for example, the dimensions of the PCB, or how many layers it has, or all that stuff. And you can also adjust it. For example, you can change the color of the PCB. And then if you want to have a assembly service, that's basically every time I order a PCB, because otherwise you would have to like solder it in yourself, and that's, if you don't have the right experience and especially the right tools, it's really hard to do yourself. And here you just fill out how many PCBs how many PCBs you want them to assemble, and we want all 5 to be assembled, and just double check everything. Yeah, nice. Then you can add it to cart. Okay, here are some legal stuff. Not creating any weapons, so you should be ready to go. Also, you will need to sign in, so you can just sign in or create an account. Now you can add those remaining files, so that the bill of materials, that's this one, those Excel files, and then the other one is the centroid file. That's basically how the components and where is their position. And now it should be ready to go. Alright, great. Following the audit, where they just inspect if everything is alright, you can select the order, proceed to checkout, and in a couple of weeks you will get the PCBs delivered to your doorstep. So thanks PCBWAY for providing me with those PCBs, and now let's get back to the voltage regulators on those PCBs. And on my chip, as you can see, it's right here, and here is the practical example. So it is already connected to the batteries through the BMS, and this switch switches from the on state and the charging state, and if it's in the on state, then the current can flow from the BMS to the regulating chip. So right now I switched it to the on state, and as you can see, the chip is receiving power from the voltage regulator, but it only uses about 200 milliamps, so I can use the additional power for whatever I want. And for example, I can operate these 1, 2, 3, 4 vibration motors like so. Pretty cool, right? And it's all powered from these batteries, no external power source. And right here you can see all those similar components. So this is the voltage regulator and teething chip, this is the inductor, these are the capacitors, this right here is the diode. But one thing that's missing in my design is this potentiometer, and that's because, and you can see that the one thing is missing, and that's this potentiometer. And that's because right here you can adjust the output voltage so it can best fit your application. So if you have a 20 volt input, it can drop down to 2 volts and you can adjust it up to, I don't know, 18 volts. So really it's more suitable for development. But for example, as I already knew that I wanted to have 5 volts and I didn't want to change it, then it's simpler design to do it without the potentiometer. And as I mentioned earlier, there are these two types of voltage regulators. And unfortunately, what I have done is that from these batteries, they output from 8.4 volts down to around 5.8 volts. And right from my voltage regulator, I'm lowering it down to 5 volts. But this chip requires 3.3 volts to operate, and it has this onboard voltage regulator, but as you can see, it's the same tech as this one, so it's not pretty efficient. It drops down to 5 volts because there are some other peripherals that also use 5 volts, and then this on-chip voltage regulator drops it from those 5 volts to 3.3 volts where this chip operates. And what I want to do in the future is set up all of those peripherals in a way that I can switch up this voltage regulator, switch it up for a 3.3 volt version, where I can then bypass this voltage regulator, and then everything can be powered from this more efficient voltage regulator, meaning that the whole controller will have higher efficiency and lower consumption. And that's a pretty cool thing. Yeah, that's a really important thing to have. So thanks guys for watching, don't forget to like this video, and also don't forget to subscribe, because in the upcoming videos I'll be explaining more parts of this controller. And bye bye!